Hello, this lesson is to explain Unit 4, Lesson 5, which deals with something called HL. This lesson will teach me to determine if triangles are congruent using HL and explain why SSA is not a method of proving triangles congruent. So explain why SSA will not work. The idea of SSA, or as some of us might like to write it, is that if you're given a particular angle and you're given a side length, and you're given another side length, that as we go and connect to create an angle, a side, and an angle, it is unclear where that needs to fall. We've discussed it in class, and this may not be the best diagram, but we did it physically with those pieces of wood, that this side can work, this angle can almost work as a hinge, that it's unclear because you're given a side, and an angle, a non-included angle, that this side can really hit anywhere. So when we did it in class, some of you were able to make a big triangle, and some of you made a smaller triangle based on the same given angle, the same side, and then the same side length given. So side angle won't work. It will work, however, if you're using a right triangle. So the idea here is when we talk about this being HL, and I'll show you two in a minute, it stands for hypotenuse and leg. So we're going to be dealing with a right triangle. I had mentioned in class that angle, side, side, and angle, side, side will not guarantee congruent triangles because this angle here works as a hinge. However, if we specify that one of these angles has to be a right triangle, then what ends up happening is if you now have a right triangle here, then the side length that you're given and the other side length that you're given aren't just any side lengths, it's the leg of a right triangle and the hypotenuse of a right triangle. So let me give you this theorem and we'll kind of go back through. But again, what we're going to do with today is a special angle, side, side. But because we're dealing with a right angle, we're no longer going to call it angle, side, side. It's going to be a special case, and this one will work. So let me go ahead and uncover this here. It says, can side, side angle ever work? And the answer is yes, only if you're dealing with a right triangle. And that leads me to a theorem called the hypotenuse leg theorem, otherwise known as HL theorem. It says if the hypotenuse, let me get my marker, if the hypotenuse and leg of one right triangle, that's probably not helpful, if the hypotenuse and the leg of one right triangle are congruent to the hypotenuse and leg of another right triangle, then the right triangles are congruent. So let me go over quickly for you. What does it mean by leg and what does it mean by hypotenuse? So when you deal with background knowledge, and I know this isn't anywhere in your notes, I would have done this kind of as a warm-up had I been in class, but in a right triangle, we have the sides that make up the right triangle. They're called the legs. The longest side of the right triangle and the one that's directly across from it is referred to as the hypotenuse. So the hypotenuse is the longest side, and these legs make up the right triangle or the right angle. So looking at this diagram over here, which one of these side lengths is the longest? Which one is across from the 90-degree angle? That's the hypotenuse. What sides form the right angle? Or think about the idea of included is this side here, which we call a leg, and this side here, which is called a leg as well. So when you look at this theorem, it says that if the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent. So you need three pieces of information for this theorem. You need a right triangle, you need a pair of legs to be congruent, and you need the pair of hypotenuse to be congruent. Hypotenuse. So look at the double markings here. This happens to be a leg. Look at the single marking. This is the hypotenuse. And then I think everybody knows that this is the right angle. So many students are used to things like, for instance, SSS, SAS. These are the other ones that we've had. And so HL feels kind of weird to have all of these triples. So if you want to think about, well, I need 3 pairs of sides, or I need a pair of sides, a pair of angles, and a pair of sides, I very often will call it RHL to represent that I need a right angle, a hypotenuse, and a leg. So whether you want to call it HL or RHL, it works the same for me. Sometimes RHL is nice because it lets you know the 3 things you need. So again, this theorem tells you that if you're given the right angle or a right triangle, one leg, and the leg could have been over here as long as you're given one leg and a hypotenuse, that the triangles are congruent. The reason why this works is because it's an angle, side, side, but it's not any old angle, it's a right angle. And in right angles, the sides are called legs, and you need a special leg. One of them has to be the hypotenuse. So we look back at this again too from that lens of angle, side, angle. Let me get a different color. Here's your angle, here's your side, here's your side. It's not in between, it's a non-included. It's a non-included angle. So instead of calling this one SSA, because we have a right angle, we have a hypotenuse, and we have a leg, we'll call it RHL. The reason why RHL works is because of the Pythagorean theorem. I don't know if you remember it, but the Pythagorean theorem says that a squared plus b squared equals c squared, where c is the hypotenuse. So if you think about this idea of a squared plus b squared equals c squared, if you were to have 2 right triangles, and let me erase something here. If you were to have 2 right triangles, and you were given, for instance, that you know this one is congruent to this one, and this one is congruent to this one, knowing that that's a 90-degree angle, you'd be able to calculate what this other value is. So it's, when you think about the idea of it calling hypotenuse leg theorem, you could ask me to prove it to you, and in that proof I would use the idea of Pythagorean theorem, because if I know 2 side lengths, then I would have to know the third. So there's just a little background info. Moving on with your notes, it says which 2 triangles are congruent by the hypotenuse leg theorem. Well, they all have right angles, so think about needing R, H, L. They all have right angles. Hypotenuse. The 5 is the hypotenuse, the 5 is the hypotenuse, and here is the hypotenuse. Nothing's listed on it, so this one's automatically out. The 3 here is a leg, the 3 here is a leg. I don't know the other leg, it's not needed. I could find it if I had to, but it asks which 2 triangles are congruent by hypotenuse leg, and then write a congruent statement. You have lots of options for your congruent statements. Pick a particular order, and whatever you pick, make sure you stick with it. So I'm going from L to M to N, so I'm going to go O to Q to P. And if you were to rearrange this at all, you'd need to rearrange those. Are the triangles congruent using HL? Explain. If you want to think about it again as RHL, do we have right angles? Yes, so this theorem can be used. Was the hypotenuse given? Well, if this is the right angle, this side length here is the hypotenuse, and this side length here is the hypotenuse. So can we use RHL? No, because the hypotenuse wasn't given. What was given? A leg, and using the reflexive property, I could have gotten the other leg, but because the hypotenuse is not marked congruent, I can't use this theorem. So idea of explanation, no hypotenuse was given. All right, and then the last slide is this one. So I'm not going to make you do a proof, but I still want us to go through and look at how we would get all these pieces and how we would prove what we need to. So it says given, let me get my pen here, given that CD, segment CD, is congruent to segment EA. So find CD and find EA and mark them congruent. Then what it tells you is that AD is the perpendicular bisector of CE, meaning AD is both perpendicular to CE. So what does that mean to be perpendicular? AD starts here to here. So it's perpendicular to CE. We can mark it with the 90 degree. And AD is the bisector of CE. So you're getting 2 for the price of 1 here. So not only is it perpendicular, but AD is also cutting CE in half, meaning that CB and EB are congruent as well. I'm going to use the double marking since the single was already used. So I marked my given. I used the idea of perpendicular by marking the boxes, and I used the idea of bisector by marking the doubles. Do I have enough information to prove that CBD is congruent to triangle EBA? And the answer here is yes. Hooray, I do. By what theorem? Because we're given a right angle, let's look to see if I can use RHL. Just because a right angle is given doesn't necessarily mean it's going to be RHL. In order to be RHL or just HL, you need a right angle. You need the hypotenuse, which is this side length here, and this side length here. So yes, and you need another leg, which is this one and this one. So yes, we can prove these triangles congruent by RHL. I just want to speak quickly about the idea of just because you have a right triangle doesn't necessarily mean you need RHL. So I know it's not in your notes, but just take a quick look at this example, that if you were given this leg and this leg and this leg and this leg, even though we have a right triangle, you don't have hypotenuse and you were given 2 legs in this particular example, this would really be side, angle, side. So please don't be fooled that just because you see a right triangle that you automatically have to assume that it's going to be RHL. It's only going to be RHL or hypotenuse leg if the right angle, the hypotenuse, and the leg are given. You can have a right angle and not necessarily need this theorem used today. So the purpose of the theorem that I showed you today is because angle, side, side doesn't work because of the idea of the angle, the side, and knowing where this other angle is going to go. So in the case that you have a 90-degree angle, the problem has now changed. And because you have something locked, the side and this other side only has one place to go. So RHL is a special way of using angle, side, side. So let me just go through what ways do we have that prove triangles are congruent. Side, 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 angle, side, angle, side, angle, 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 side, and now RHL standing for right hypotenuse leg. The ways that don't work, side, side, angle, or whether you want to call it the other one, still doesn't work. It'll only work in the special case that you have a right triangle. And angle, angle, angle won't ever work for the idea that it involves a dilation, as we discussed previously in class. Please do the best you can with this material. Write down any questions or concerns you have, and I'll see you at a later date. Thank you so much.